High-ranking military officials now admit 3I Atlas may not be what it seems, but something far more terrifying.
But on October 19th, 2017, Pan-STARRS spotted an object moving rapidly between the stars. By October 22nd, we had enough data to realize that this object wasn't from our solar system.
For weeks, astronomers watched a faint visitor from the stars, 3I Atlas. NASA offered cautious updates, but hidden images told a darker story. Now Harvard scientists have revealed a terrifying possibility, and Avi Loeb's bold words have unleashed a storm of questions. Is 3I Atlas truly an interstellar comet, or something far stranger? And why would NASA try to keep the truth from us? Join us as we uncover what Harvard has just revealed about 3I Atlas, a silent interstellar visitor. When Comet 3I Atlas first appeared on telescopes' screens in mid-2025, it seemed like a routine discovery. Astronomers using the Atlas Survey telescope in Rio Hurtado, Chile, noticed a faint blur darting across the starry backdrop. Its motion was unusual, its speed extreme, and its orbit didn't belong to anything known within the solar system. This was an interstellar visitor, only the third ever recorded, following the enigmatic Oumuamua in 2017 and the icy wanderer Borisov in 2019. The object was formally logged on July 1st at magnitude 18. At the time, it was more than 3 astronomical units from Earth and racing inward at over 61 kilometers per second, roughly 140,000 miles per hour. Initial calculations placed it along the border of Serpens Cauda and Sagittarius, near the crowded star fields of the galactic plane. For a few hours, the Minor Planet Center even listed it on the Near-Earth Object Confirmation page, until further data showed it was bound not for Earth, but on a hyperbolic trajectory through the solar system. Follow-up detections came quickly. The Zwicky Transient Facility traced it back into late June, while amateur astronomers spotted still earlier images hidden in dense star fields near the galactic center. By July 2nd, multiple observatories confirmed a faint coma and a possible tail, proving it was a comet. The designation followed, 3I, marking it as the third interstellar object, and Atlas, its formal cometary name. Within days, over 100 observations from dozens of observatories had been logged. Polarimetric data revealed an unusually high degree of negative polarization, suggesting its dust grains were a mix of dark and icy material, unlike most comets studied before. The Vera C. Rubin Observatory, still in its validation phase, captured images showing a steadily expanding coma. NASA's TESS satellite added further intrigue with earlier pre-discovery images from May 2025, already showing the comet active at a distance where most remain inert. This activity hinted at volatile ices far more exotic than ordinary water. At first, models suggested safety. JPL ran projections showing 3I Atlas would pass near Mars in September before slingshotting toward the Sun and back out into interstellar darkness. The narrative was simple: a rare spectacle, harmless, and a scientific windfall. But then, the orbit changed. As August progressed, refinements to its trajectory revealed subtle deviations. At first, they seemed like statistical noise. Comets often shift course slightly under the push of asymmetric jets of gas. Yet, instead of random drift, the changes appeared deliberate, small, precise, and consistent. By early September, Harvard astrophysicist Avi Loeb and his colleagues published recalculations. NASA's Jet Propulsion Laboratory independently confirmed the same troubling signal. The comet was not drifting passively. Its path was adjusting, bending closer to Mars's orbital corridor. The shifts were minuscule, mere fractions of an inch per second, but across tens of millions of miles, such nudges became decisive. Over time, they narrowed the safety corridor instead of widening it. Outgassing alone could not account for the accuracy. Loeb described them as the fingerprints of control, likening the comet's micro-adjustments to the maneuvers of a spacecraft using thrusters. Every recalculation tightened the projection. Where once there had been a comfortable distance, the models now converged on a narrow corridor slicing straight toward Mars. If contact occurred, the outcome would be beyond catastrophic. Mars, once expected to host a harmless flyby, now lies directly in the line of fire. And then came a new mystery: the coma itself. By every known standard, it should not exist in the form observed. The unusual space anomaly. A comet's coma, a halo of gas and dust, forms as it nears the sun. Normally, sunlight warms frozen ices, gas vents from the surface, and a diffuse glow develops around the nucleus. But 3I Atlas refuses to follow the rules. Data from NASA's Mars Reconnaissance Orbiter revealed that its coma did not grow steadily as expected. Instead, it doubled in brightness within weeks. Instruments also detected sudden spikes of high-energy ultraviolet light, emissions that simply do not occur in ordinary cometary activity. In familiar comets, venting stabilizes as the body approaches the sun. They brighten, shed gas, and the process smooths out. 3I Atlas behaved differently. Spectrographs showed massive outflows of carbon dioxide at rates far exceeding anything previously recorded. Yet the nucleus remained intact, as if controlling the release. Plumes emerged not randomly, but in pulses, almost as if timed. Instead of dispersing chaotically, the jets seemed to steer, aligning with the comet's shifting trajectory toward Mars. Each brightening and ultraviolet spike corresponded with small but measurable course changes. For researchers accustomed to chaotic cometary behavior, the precision was shocking. Two possibilities arose, both extraordinary. 3I Atlas could be a new, unknown type of interstellar comet, or it could be a deliberately engineered object, an icy shell hiding a machine using gas plumes as thrusters. On July 16th, Avi Loeb and colleagues from the Initiative for Interstellar Studies went public with that suspicion. In a paper posted on ARXiv, they argued that 3I Atlas might be a spacecraft, not a comet. Their reasoning: its enormous size, puzzling spectral gaps, and its near-perfect alignment with the solar system's ecliptic plane. The backlash was immediate. Astronomers like Chris Lintott dismissed the claim, and Darrell Seligman, who had led the first study of 3I Atlas, pointed out that telescopes had already recorded classical signatures of cometary activity. Webb, Swift, and the Very Large Telescope soon confirmed the outgassing of familiar chemicals: carbon dioxide, water, cyanide, and nickel vapor, consistent with natural comets. Yet, the controversy refused to fade. By mid-September, as the comet approached Mars, astronomers faced a sobering reality. It behaved less like a drifting comet and more like a guided vehicle. For engineers, the comparison was unavoidable. This resembled the operation of attitude thrusters, small maneuvering jets used on spacecraft to control direction. Over multiple nights, the pattern remained locked in phase, like a metronome. Even small bursts imparted measurable force, gradually closing the remaining gap between 3I Atlas and Mars. By mid-September, calculations suggested the missed distance could shrink from millions of miles to under 50,000, closer than the orbit of Mars's small moons. A single well-timed outburst could tip the trajectory fully into collision. For the first time, many scientists voiced what had seemed impossible. This was no ordinary comet. It behaved like a vehicle, and Mars might be its target. the Mars collision window. By mid-September, discussions about 3I Atlas had focused on a single chilling concept: the Mars collision window. Scientists had been tracking its 17-minute pulses for weeks, each acting like a subtle maneuvering jet. When those micro-adjustments were incorporated into orbital models, the conclusion was unavoidable. This object wasn't merely passing by, it was threading a needle, steering ever closer to Mars's path. Official calculations placed its closest approach at 1.2 million miles on September 26, 2025. In cosmic terms, that distance is alarmingly narrow. For context, Earth's moon lies only 238,900 miles away, while Mars itself measures roughly 4,200 miles across. A pass within 1 million miles may sound safe on paper, but for planetary scientists, it is a razor-thin margin. At such proximity, Mars's gravity becomes a tangible force, capable of nudging the object enough to reshape its trajectory. The danger is compounded by the comet's instability. Every 17-minute plume pushes it slightly sideways, and every gravitational tug from the Sun, Jupiter, and now Mars amplifies those shifts. What began as a seemingly harmless flyby has become a perilously narrow corridor, where even the smallest push could tip the outcome. Calculations released in early September made the threshold starkly clear. A velocity change of just 6 miles per second could send 3I Atlas directly into Mars. In interstellar terms, this is a minor adjustment, the kind a single strong outburst or deliberate thrust, if the object is artificial, could provide. During the critical window between September 19th and 30th, the comet aligns almost perfectly with Mars's orbital plane. Any course correction, no matter how slight, could lock in a collision. If the 17-minute rhythm persists, projections indicate the missed distance could shrink from over 1 million miles to less than 30,000, bringing it closer than Deimos, Mars' outermost moon. The stakes are enormous. Mars hosts dozens of active missions, including the Perseverance and Curiosity rovers, the Mars Reconnaissance Orbiter, the ExoMars Trace Gas Orbiter, and more. A near miss could saturate Martian orbit with debris. A direct strike could obliterate years of exploration. As September progresses, the collision window looms ever larger. Whether 3I Atlas merely grazes past or strikes Mars, one fact is clear. The red planet is about to face its closest encounter with cosmic fate in billions of years. What happens if it hits Mars? Speculation about a close pass is alarming enough, but the prospect of a collision is staggering. Based on radar echoes and brightness models, scientists estimate that 3I Atlas carries a mass on the order of 10 billion tons. Beneath its glowing coma lies a dense metallic heart, perhaps 1,300 feet across, wrapped in ice and dust. Hubble's high-resolution images from July reveal a nucleus somewhere between 0.3 and 5.6 kilometers in diameter. The range is wide because the comet's core is buried under a brilliant haze of reflective dust, making it appear larger than it really is. Some early studies even suggested a size of 10 to 20 kilometers. But astronomers now lean toward the lower end of the scale. For comparison, the object that wiped out the dinosaurs 66 million years ago was about 10 kilometers across. 3I Atlas is likely smaller, but its speed makes it uniquely destructive. Traveling at nearly 194,000 miles per hour, it is moving 10 times faster than a rifle bullet. At that velocity, even a modest-sized nucleus packs colossal power. The Chicxulub impactor, which struck Earth and triggered a mass extinction, released energy on the order of 100 million megatons of TNT. A direct strike from 3I Atlas on Mars would unleash about 2 million megatons, smaller but still catastrophic on a planetary scale, thousands of times greater than the most powerful nuclear device ever detonated on Earth. Observations by the Swift Observatory hinted at a possible 5-kilometer diameter, but this too is likely inflated, as much of the measured water vapor comes from the coma rather than the nucleus itself. The comet is a master of disguise, cloaking its true size beneath clouds of dust and gas. James Webb's instruments provide sharper clues. Spectra from August show the comet shedding nearly 130 kilograms of carbon dioxide every second, alongside smaller but steady emissions of water vapor, carbon monoxide, and the rarer gas carbonyl sulfide. For comparison, Halley's comet at peak activity vents thousands of kilograms of water per second, but only modest amounts of carbon dioxide. 3I Atlas is inverted, relatively water-poor but rich in carbon dioxide, making it unlike any comet measured before. The water ice grains drifting in its coma are microscopically fine, less than a micron across and likely amorphous, formed in conditions far colder than crystalline ice allows. These grains do not seem to sublimate directly from the surface. Instead, they appear lofted into space by violent gas eruptions, suggesting deeper reservoirs feeding sudden outbursts. The Very Large Telescope in Chile adds to the puzzle. It detects ultraviolet signatures of cyanide gas and, surprisingly, atomic nickel. Nickel itself is not unusual. It has been seen in comets before, Borisov, but the absence of iron, which normally accompanies it in equal measure, is striking. Between July and August, VLT records a steady rise in nickel and cyanide emissions as 3I Atlas closes in on the Sun. The precise process of freeing nickel into space is unknown, and the imbalance with iron remains one of its strangest chemical signatures. Equally puzzling is what the telescopes do not see. Standard cometary gases like atomic oxygen, dicarbon, and tricarbon are absent, leaving 3I Atlas among the most carbon chain-depleted comets ever recorded. Its carbon dioxide to water ratio is extraordinary, 8 times higher than expected, placing it among the richest carbon dioxide emitters on record. The only comparable case is Comet C 2016 R2, itself an oddball. Whether 3I Atlas formed in an exotic environment saturated with frozen carbon dioxide, or whether its water is trapped beneath a thick insulating crust, remains an open question. The comet rotates slowly, once every 16 to 17 hours, though its dusty veil makes the exact spin difficult to measure. Its brightness variations dim over time as activity increases, suggesting outgassing is cloaking more and more of its surface. Even its orientation in space remains uncertain, with different models pointing its north pole in contradictory directions. Yet, the true danger lies not in its slow rotation, but in its raw momentum. A dense metallic body, wrapped in ice and driving straight toward Mars's orbital corridor, carries more destructive potential than any cometary visitor in recorded history. If 3I Atlas were to strike, the event would rewrite the Martian landscape. The impact would gouge a crater 37 miles across and over 3 miles deep, wider than Los Angeles, deeper than parts of the Grand Canyon. By comparison, Arizona's meteor crater, formed by an object only 50 meters wide, is just 3/4 of a mile across. 3I Atlas would carve something on the scale of the Great Basins that scar Earth's moon. The violence would not end with the crater. Rock and ice would vaporize instantly, lofting cubic miles of dust into the sky. Mars' thin atmosphere offers little resistance, so debris would arc high into orbit before raining down. Some would settle as a choking haze, while the rest would be hurled into space at escape velocity. For exploration, The consequences could be devastating. Rovers like Perseverance and Curiosity could be buried in dust or struck by fragments. Ingenuity, still flying occasional sorties, would likely be destroyed. Orbiters such as the Mars Reconnaissance Orbiter, MAVEN, and ESA's Trace Gas Orbiter would face lethal clouds of high-velocity shrapnel, cutting off the satellites that maintain Earth-Mars communications. Billions of dollars and decades of human effort could vanish in an instant. This danger recalls the Shoemaker-Levy 9 event in 1994, when fragments of a comet slammed into Jupiter with explosive force, leaving Earth-sized scars in the giant's atmosphere. That collision was safely distant, a spectacle through telescopes, but 3I Atlas offers no such comfort. Mars is crowded with active spacecraft, and its orbital environment is delicate. A major impact could cripple exploration for years. Beyond hardware, the Martian environment itself would change. Dust storms, already a hallmark of the planet, could darken skies for years. Global storms in the past have already blanketed the entire planet, cutting off sunlight for months at a time. With an impact of this scale, the dust load could be far greater, driving long-term cooling and choking off solar-powered missions. Subsurface ice near the impact zone would flash to vapor, possibly creating temporary geysers or new atmospheric chemistry. Trace gases, carefully monitored by missions like ExoMars, would be contaminated by the aftershocks of impact. Even the search for life could be compromised, as debris sterilizes once promising sites or buries evidence beneath layers of fallout. The risk does not end at Mars. Debris flung into space could scatter across interplanetary orbits. Some fragments would spiral toward the Sun, but others could drift outward, crossing the paths of Venus or Earth within decades. This echoes the Tunguska event of 1908, when a relatively small comet or asteroid exploded over Siberia, flattening forests across hundreds of miles. 3I Atlas would be orders of magnitude larger, and though its impact zone may be Mars, the shards it ejects could seed danger across worlds. For planetary defense experts, this is the nightmare scenario. Humanity has rehearsed asteroid impacts for decades, tracking near-Earth objects and developing strategies for deflection. But no scenario anticipated an interstellar object, one moving faster than anything in local space, unpredictable in chemistry, and resistant to standard assumptions. With 3I Atlas, there is no established playbook. Speculation about a close pass is alarming enough, but the idea of impact carries implications far beyond one planet. Mars could be scarred for millennia, its exploration program set back a generation, and its skies dimmed by dust. Earth and the inner planets could inherit the long-term risks, facing fragments hurled into new orbits. The last time a collision of this magnitude struck our solar system, dinosaurs vanished from Earth. This time, the target may be Mars, but the consequences would ripple outward, reshaping not just one world, but the very architecture of the inner solar system. Signals of something artificial. As the threat window narrowed, scientists probed deeper into the mysteries of 3I Atlas. ESA's Mars Express captured faint glints above the red planet, repeating across 3 consecutive orbits. They formed a triangular pattern that held position, behaving less like drifting debris and more like probes on station. If 3I Atlas had released them deliberately, the implications were staggering. While suspicions grew, astronomers returned to the basics. Where had this thing come from? Its hyperbolic orbit and extreme speed proved it did not belong to the solar system. Tracing its path showed that it had entered from the southern skies. out of the constellation Sagittarius, near the Milky Way's core. That was surprising. Most expected interstellar visitors to approach from the solar apex, the direction of the sun's motion. Instead, 3I Atlas came from the opposite side, hinting that these objects might be more common and stranger than anyone believed. Calculations revealed just how alien this traveler was. Its motion carried it away from the galactic center at more than 50 kilometers per second, tilted steeply above the plane of the Milky Way. That trajectory linked it to the galaxy's thick disk, a population of ancient stars with fewer heavy elements than our Sun. If so, 3I Atlas might be older than Earth itself. Some estimates placed its age at up to 14 billion years, nearly as old as the galaxy. A fragment of cosmic history had wandered into our neighborhood, carrying secrets from an era before our solar system even formed. The mystery only grew as the comet approached Mars. Amateur astronomers reported that its tail no longer spread as a diffuse fan. Instead, it split into 3 sharp beams, glowing an unnatural green. At first dismissed as photographic artifacts, the pattern was confirmed across telescopes worldwide. Each beam pulsed in sync with the 17-minute rhythm, brightening with every plume. At long exposures, the streams appeared to converge toward Mars, as if pointing the way. Natural comets sometimes glow in color, but never in such sharp, synchronized patterns. The precision suggested coordination and possibly intent. If the object was artificial, or even partly engineered, those streams could contain exotic materials, nanotechnology, synthetic compounds, or even biological agents hidden within the core. Scientists called this risk forward contamination, the possibility that material from beyond the stars could seed Mars, Earth, or the inner planets. The green beams were more than a visual oddity. Their alignment toward Mars hinted at guidance. Their unnatural glow suggested hidden processes inside. And their potential to spread debris across the solar system transformed the threat from a single planetary impact into an interplanetary crisis. Whether 3I Atlas was an ancient wanderer behaving in ways no one could explain, or something deliberately guided across the stars, one truth became undeniable. Its approach to Mars was no ordinary cosmic flyby. It was a test of how humanity responds when the unknown arrives, not as a mystery in the distance, but as a presence on our doorstep. What NASA isn't saying. As September unfolds, telescopes across the world fix their gaze on 3I Atlas. Every pulse, every flare, every shimmer of its strange green tail is logged in real time. Data streams pour in night after night, yet the official response grows eerily quiet. NASA issues calm, almost generic bulletins, calling it an object of interest. The European Space Agency releases routine images but adds no interpretation. Japan and China confirm they are tracking it, yet hold no public briefings. The silence raises questions. Behind the scenes, however, an entirely different picture emerges. Leaked documents suggest NASA has reassigned the Mars Reconnaissance Orbiter, no longer just a Martian mapper but a forward radar platform. Its instruments now sweep the interstellar intruder. Goldstone's massive antennas, normally used to talk with spacecraft across the solar system, redirect their beams to bounce signals off the comet's heart. The echoes return sharper than expected. Metallic reflections where porous ice should be. Something about the nucleus defies the profile of a normal comet. Meanwhile, in Europe and Asia, emergency task forces meet under closed doors. Fragments of meeting notes point to conversations about planetary defense, protocols usually reserved for asteroid impacts on Earth. For the first time in history, scientists debate whether humanity should intercept or even destroy an interstellar object. The idea sounds impossible, No rocket can match its speed. No missile can reach it in time. Yet, letting it slam into Mars unchecked seems reckless. The possibility that it is more than natural, perhaps even artificial, deepens the unease. Time itself becomes the enemy. By the time 3I Atlas is spotted on July 1st, the window to launch a direct pursuit from Earth is already closed. To catch it now would demand a staggering delta V of at least 24 kilometers per second, far beyond the reach of any existing rocket. The chance is lost before humanity even knows it exists. Calculations reveal a bitter truth. Had a probe been launched the very day of discovery, a manageable 7 kilometers per second would have been enough for an intercept. That door is now sealed, but another door opens. A July study by Atsuhiro Yaginuma and his team shows that from Mars, the math changes. A launch from the red planet between July and September requires only 5 kilometers per second to stage a flyby in October. Suddenly, the impossible begins to look almost within reach. If humanity can act fast enough, even if no new mission is rushed into existence, the solar system already has sentinels in place. As 3I Atlas sweeps towards Mars in late September, orbiters circling the planet can turn their cameras and sensors toward it. If 3I Atlas just passes Mars, by March of 2026, the comet will drift near Jupiter. In theory, Juno could catch a glimpse, though its dwindling fuel and failing thrusters make success unlikely. Other spacecraft hover closer to destiny. Astrophysicist Marshall Eubanks calculates that NASA's Psyche mission will pass within 0.302 astronomical units on September 4th. Just weeks later, ESA's JUICE spacecraft will swing even closer, 0.428 astronomical units, or 64 million kilometers, on November 4th. Engineers quietly weigh whether these billion-dollar craft, designed for completely different purposes, should risk precious resources to observe a fleeting stranger. Back on Earth, one eye stands unmatched: the James Webb Telescope. Webb is not designed to chase comets, but from its distant perch at L2, it does not need to. Its 6.5-meter gold-coated mirror collects more light than Hubble 6 times over. Its instruments dissect faint infrared glows invisible to the naked eye. Already, Webb has detected carbon dioxide, water, and carbon monoxide streaming from the green-tailed visitor. Each new observation tightens the mystery. A comet that shines like no comet before. One that pulses every 17 minutes, like a machine keeping time. Webb's NIR-CAM will be able to capture precision imagery while serving as the alignment eye for its segmented mirrors. NIR-SPEC splits incoming light into hundreds of chemical fingerprints. MIRI plunges deep into the mid-infrared, cold enough to track dust grains that barely radiate heat. Together, they make Webb a tool capable not just of observing 3I Atlas, but of interrogating its chemistry at the molecular level. Yet the deeper Webb looks, the more questions rise. Could this be an entirely natural phenomenon, stranger than any comet seen before? Or could the 17-minute rhythm, the metallic echoes, and the structured outgassing suggest something manufactured? The stakes shift from scientific to existential. Destroying it might erase the first evidence of extraterrestrial technology. Allowing it to strike Mars might spread unknown material across the solar system, perhaps even toward Earth. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.